Hello, everyone. We are the Flux Place, and our project is the food allergy detector. So for many of those who have food allergies, it could sometimes be difficult to be sure that the food is okay for you to eat. Well, the food allergy detector can detect 5 of the most severe allergies: peanuts, tree nuts, eggs, dairy, and shellfish, when given an image of the dish. This would obviously be helpful in being extra careful in figuring out what to eat to ensure the safety of our users' health. So to create this model, we used various tools. We used Kaggle and web scraping to collect images for the model's dataset. We used RoboFlow to help us label and set augmentations for our dataset, and YOLO v5 model was used to train our model. We used weights and biases to analyze the performance of the model after each training session. And for our website, we used HTML, CSS, and JavaScript for both the front end and the back end of the website.
And for the data set that we gathered for our model, we collected various images of the dishes and individual foods that fit into our 5 categories by web scraping Google Images through SERP API. And we collected these images and then annotated them using RoboFlow, mixing bounding boxes and polygonal selection annotation to add diversity to increase our model's accuracy. Then we can see this chart here to see the distribution of our 5 categories. We actually decided to not include the fish category as it strayed our data, and it's one of the lesser categories as far as allergens goes. And you can see here, out of our 2,000 images, 263 of them were background images that were set as null to help train our model to recognize the difference between a background and our data as in a dish. So we can lessen false negatives. And for our scripting, we used, there's links here on our README file, and we can link the GitHub page in the chat at the end of our presentation. Our web scraping collab that we use to web scrape Google Images with our SERP API code. And then we have our model training collab with our model training notebook on it that we used the YOLO v5s object detection model to train our data from RoboFlow. And then, as Joshua mentioned earlier, weights and biases to analyze the metrics so we can really streamline our model to be as accurate as possible. And I'll hand it over to Jennifer for our model training.
Okay, so as mentioned before, we use YOLO v5 as our model. In addition to that, I'll just go over like the hyperparameters and what they mean. So DIM stands for dimensions, and that's 416 by 416. It's what we resized each image in our data set to be so that it's easier for the model to analyze. And a batch size is because our data set is after data augmentations around 5,000 images. So we have to make each batch smaller so that the performance is higher. So 64 is the number of images in each batch. Epochs refers to one epoch is when the data set has ran through the model backwards and forwards and backwards through backpropagation in order to set the weights. And we did that 100 times. We also tried 200 and 300, and 300 worked, but we at first we used 100 just for the sake of time. But we didn't get any overfitting for 300 epochs. Now to move on to the metrics. So the confusion matrix states what percent of our predictions were true positive. You can see in the middle there, the diagonal line that refers to the true positive. Where it says background of P, that's the true negative. And then where it's actually the most rightmost column, that's that's actually a false positive because the predicted is a class, but it's actually a background, and the column is a false negative. And we can see here that our model did pretty well. The true positive is pretty good. So in addition to that, I'll just hand it over to Joshua to talk about the rest of the metrics.
For the MAP curve, it shows the average of the area under the precision / recall curves for putting a bounding box for each of the 5 labels. The larger the area, the more accurate the model is in detecting the allergen in the dish. So when you look at the graph, you can see that over 200 epochs, the model was able to reach over 0.7 at a consistent basis. For the PR curve, it's a curve that shows both the overall precision and recall for each of the 5 labels. An effective model should try to have a high precision and recall. So looking at the graph here, for tree nuts, there's a much smaller area compared to all the other labels. However, the model does a pretty good job in detecting most of the allergens when creating the bounding box in the dish. And then for the training metrics, the model was accurate in setting up the right bounding box of the allergen, detecting the allergen, and classifying the allergen as the epochs increased. For the validation phase, the metrics was consistent. The model, was consistent in its good performance, which is obviously a good sign. And back to Jack for the website and the demo of our model.
So thank you, Joshua. So for web deployment, we used the Python framework Flask and CoCalc, and also today imported our data onto our local files. And you can find, here's a little tutorial to, after downloading our files, how to deploy it down here. And then let's just head over to our website here. So here's our food allergy detection website. And as we scroll down to the website, we can get a little gloss over what we just spoke about in the README file, and then down here, actually, I'll take advantage of the nav bar right here, the process that we went through, and then the metrics, and then after this demo, we'll go on to the improvements and uses from Quaashie, and then we have our GitHub repository and our team page, so you can get a little overview of everyone in our team. And yeah, so let's go up here and let's get into the model. Oh yeah, the send feedback page also works. So let's get into our model. We have a few images here that we can demonstrate from a few of our, oops, let's not do that, from a few of our categories. And so let's, I'm personally allergic to peanuts, and one of the most common peanut dishes is pad thai. So let's drop in an image of pad thai. We can see here that our object detection model recognizes peanuts in the pad thai, even though it's not overtly obvious even that pad thai has peanuts. And then we can even actually just go here. We can drop in another. Perhaps eggs, and then we can see our confusion matrix here also. The model identifies eggs, and then if we go to something like dairy, perhaps a glass of milk, obviously that could be quite more obvious for the user, but let's go to something a little more strange. How about an egg roll? It knows it's eggs. So even though from the vast difference in color and brightness values, it's still, we've trained our model to recognize different dishes. So actually, I think there's one more that we can demonstrate, and that is from the shellfish category, yes. And just to show that our model recognizes this lobster here. So then I'm going to hand it back to Quaashie for future works and improvements.
Thank you, Jack. So for future works and improvements, we plan on adding more images to our current data set so we can increase our model's confidence and sort of decrease the background false positives. We also plan on adding more labels. So as Joshua said earlier, we did plan on adding fish and soy to our labels, but we didn't have the time to do that. But hopefully in the future, we will add these 2 labels and add more allergens. Also, we plan on doing multi-labeling because pad thai actually has more than peanuts. It also has wheat, fish, shellfish, soy, eggs. So by using multi-labeling, our model will also be able to say more than one allergen. Also, we plan on using the polygon function, but you can't really see the image. But basically on RoboFlow, one of the how we label, there's a function that allows us to use a polygon, sort of like that fish image. If you can go back down, Jack. Oh yeah, that. So it can exclude the background and only include the food. That will also help to decrease the background false positives. Also, hopefully in the future, we will be able to convert our model into an app to make things more simpler for people to use, and also have our model be able to identify and track moving objects, sort of like in the photo, how people will be walking in the street, our model will be able to notice them and identify them. Thank you for listening to our presentation. Are there any questions?